I'm Cyberdarsh. I'm a cyber systems engineer, and I'm on social media teaching cybersecurity and IT. All right, guys. So I've been playing around with the Home Lab. I did something really fun with my current main computer setup and the hypervisors that I've been using, the Proxmox hypervisor. I now have two hypervisors, right? I got another Dell Optiplex off of Facebook Marketplace, and I loaded that with Proxmox. We're going to join them and make a cluster, but we haven't done that yet. But I was playing around, and I do have my network diagram up. You guys know how I love my network diagrams, and I wanted to show you what I did. It's actually really cool. Do you have to do it? No, but it's cool to understand some networking concepts and what is possible, right? With a lot of things in IT and networking and cybersecurity, there are many ways to get to your objective, and this is just one of those ways. So previously, the management interface of my Proxmox server was routable through the home router. So if I was on my home network, I could browse to the management interface of my Proxmox and then do everything from there. But what I wanted to do was isolate it. And so what I ended up doing was bringing it to physically closer to my actual computer, which is denoted as this PC right here. I didn't want to run a very super long Ethernet cable from the home router to either one of the servers or to this new switch that I got off Facebook Marketplace, right? I did not want to do that. So that brings me to a dilemma, because now these Proxmox servers are isolated, right? They're not connected to the internet. How do I connect to them? I have nothing connected to them. Right now, I have two Proxmox servers that are both connected to this layer 2 switch right here, right? But how do I connect to them now? How do I manage them? How do I browse to the management interface? What I then did was, on the second NIC of the main computer that I use, I connected that second NIC with an Ethernet cable. I connected it to the switch. And so now the main computer that I'm using is on the same layer 2 domain as the Proxmox servers. But then now comes another dilemma. These two Proxmox servers already had their IPs, 192.168.1.190 and 191. I did not want to re-IP them. I don't know, I was lazy. It is what it is, but it allows us to do some creative stuff. I did not want to re-IP them. So when I'm using my computer, this PC right here, how then do I browse to their management interfaces? They're on two different subnets. My main PC is connected to my home Wi-Fi. That's why you see this connection right here between the PC and the Wi-Fi. It's on the Wi-Fi network. This is my Wi-Fi provided IP address, the .4.25. But that's not on the same subnet as these Proxmox servers. So with this second NIC, the Ethernet connection to the switch, I IP'd that. And what I did was I put it on the same subnet. I gave it a .1.240 IP. Now, by doing that, this PC, this network interface card, is on the same subnet as these two Proxmox servers. And what that allows us to do is, when using this computer, I can now browse to the management interfaces of these Proxmox servers. They're on the same subnet. They're connected to a switch that connects them all on layer 2. And I can now browse IP to the Proxmox interfaces. And now I can do all that. It's cool. The other cool thing is we've isolated the Proxmox servers and all the VMs that are sitting on these hypervisors. They're isolated. The only way to connect to them now is from this Windows computer. Everything else in this home network has no knowledge of these Proxmox servers because they are on a different subnet and they are on a different layer 2. There is no way for any of these other devices here to route to these Proxmox servers. My home router, there is no route. It has no idea. So the only way to interface or interact with these Proxmox servers is if it is coming from this PC. So we've created a really cool security boundary in that regard. And I was like, oh, that's really cool. Awesome. Then I ran into the next dilemma, which brings me to the reason why I'm making this video is, since these Proxmox servers are now isolated, how do they get their updates? How do I update these Proxmox servers? Now, of course, we can get all the packages, all the updates loaded onto a USB and then sneaker net it into the hypervisors and run the package updates that way. Do I really want to constantly be doing that? Is this a super secure network that has to be air gapped and can't get packages from the outside world? No. Right? This is my home network. I'm going to find out a different way to do this, a different way to get these packages. Okay, so how do I do that? By essentially turning this Windows computer into a router. Okay, Windows has native routing capabilities built in that you can turn on and configure. So what we're going to do in this video series is I already did it. So I'm going to show you how I turned this Windows computer into a router. We set up a NAT, right? A network address translation, and a router to forward packets. So the end goal, what we've been able to accomplish, is when these systems send packets and they hit their gateway, right? Their gateway IP, which is this, right? And if you don't know what a gateway is essentially your ingress and egress points, your actual door to your network. That's your gateway. It's the edge of your the network that your system is sitting on. This .240 is the gateway for these two systems. What we've been able to do with the forwarder, with the NAT, with the router, is when my Windows PC receives packets from this subnet, these two devices, when it receives packets on this IP, this gateway, forward it. And now the packets coming from here go here through the switch to the Windows PC, out, and then go out to the internet. By doing that, we have essentially allowed our hypervisors to connect to the internet and get their updates. And it's secure because still other systems have no way to reach these Proxmox servers. It's only the Proxmox servers that are able to go out. I have not established any kind of route for any of these systems to be able to communicate with my Proxmox server. So that's what we did, and it works. But let me show you what that actually looks like. So step one is enabling globally on your Windows computer, enabling the routing service, the routing function, right? There is a registry key that we have to enable. Now, you can browse your registry editor, right? If you go to regedit, you can go to computer, local machine, system, current control set, services, TCP IP parameters, and the actual thing that we need to enable routing is this thing here. It's called IP enable router, and we have to set the value to 1. All right, if we set it to 1, that's how we enable it, right? If you double click this, you can put a value data of 0 to turn it off, or you can do a value data of 1 to enable it. So again, you can browse the registry to do that. Just go through all these folders, or through the awesome use of our good friends Codex or Claude or whatever AI tool you want to use to generate your scripts for you, we can just do that via PowerShell. So you can do a set item property, and this is the path, right? This is the path that I just showed you. Manually, we could have done it just by browsing through this. Name IP enable router, right? That's this IP enable router here, and we set it to a value of 1. So you just use this script, these commands, and you press enter, and it makes the registry edit change for you. That's the first thing that we did, right? Number 1, we enabled the routing function. But that doesn't mean anything yet, Because now that we've enabled the routing function, how does the Windows computer know what to route between? Which adapters on your Windows computer, which adapters to route between, right? Because when we talk about the function of routing, what is the function of routing? The function of routing is to send packets from one subnet to another, from one network to another. That is routing, okay? So we need to have our PC know, okay, if you're getting packets from this network, send it to this network. How does it know that? Now we need to select the actual interfaces. And on my Windows computer, I have two interfaces. I have the adapter that's holding the .4.25, right? That's the main network facing adapter. And then I have this other adapter that I connected to the switch, the .240. I need to route between these two. I need to make sure that if traffic comes into here, into the .240, it routes to .4.25. Okay, that is routing. That's what we need to do. So how do we do that? Let's pop open PowerShell again. And what we're going to want to do is enable forwarding on both of our interfaces. Okay, and how do you know? How do you know which interfaces to actually use, right? If we open up your network settings, this is just my network settings. I have a bunch of adapters right now, but before I did everything, I had the Ethernet adapter here. This is the actual network interface card on my computer that has an Ethernet cable connected to the switch in the Homelab. Okay, that is one of my adapters that's facing the Proxmox servers. It has the .240 IP, and then I have my Wi-Fi adapter. My Windows computer is using Wi-Fi. It's connected to my Wi-Fi network, so I have that adapter. So we need to route traffic between these two adapters, right? One is called Ethernet, one is called Wi-Fi 2. That's just the name of the adapters that I have. So how do we do that? We turned on routing, but remember, we need to say, hey, if you get an IP from this, if you get a packet from this IP, this network, this card, forward it to the next card, right? We know that one of my adapters was Wi-Fi 2, okay? And then you do forwarding enabled. So we're turning on forwarding for this one. You hit enter, cool. And then do the same exact thing for your other interface. Whatever that may be called on your computer, mine was simply called Ethernet before I did all this, okay? So now we've enabled forwarding for both of those adapters, right? Forwarding is turned on for them. So now we've turned on forwarding, okay, for those interfaces. But now we need to create the NAT, the network address translation, that says, hey, when packets come from this subnet, forward them to the other interface, but convert them, make it look like they're coming from this IP. When we create the NAT, when the IP goes through, gets forwarded from one interface to the other, it comes out the other side as the other IP, the IP that we want, that we're setting. Okay, because that IP, after it gets natted, is able to route through our main network. So that's what we need to do now. So let's open up PowerShell again, and we're gonna do a new NAT. Okay, new NAT, create a network address translation, call it Proxmox Lab. That's what we're naming it. You can name it whatever you want. Now we're setting it, hey, this is the internal, this is the IP that you're looking, this is the subnet that you're looking out for. 192.168.1.0, and this is a /24. Now you can change this, you can scope this down, but we're gonna do a /24, and you'll notice that the 1.0/24, our Proxmox servers are on that subnet. So we'll create this NAT so that our Windows computer knows to look out for packets that are coming from the subnet that the hypervisors are sitting on. Awesome, we have created our NAT. Okay, and you can test it by doing, you can confirm that by doing a get net nat, and you'll see something will pop up. We've created Proxmox Lab 192.168.1.0/24. That's what we want, right? We're saying, hey, look out for IP, look out for packets that are coming from this subnet. Is it active? It's true. So when the packets hit that interface, the Ethernet interface, it'll get forwarded, it'll get routed to the Wi-Fi 2 interface and come out NATed, right? The IP, the source IP changes. The source IP now becomes my Windows computer's IP. That is what's going to happen, okay? Because that Windows computer, its IP can traverse our home network and get out, right? The Proxmox servers cannot. That's why we're doing this whole thing. So we have created the NAT. Now, what do we do next? We have to go into our Proxmox servers and change their gateway settings. We have to say, hey, anytime you are trying to communicate with an IP, if you cannot find that IP on your subnet, send the packet to the gateway. That's what we want. That's what we want, right? Send the packet to the edge, which just happens to be our Windows computer. You see, we're connecting everything, right? This IP here is the gateway, and we're saying we need to tell these Proxmox servers, send your packets to the gateway IP. So we'll go into one of the Proxmox servers that we've been using this whole time. Go to our actual node right here, PMS001. Let's click on network. And we have our bridges and our two NIC devices. VMBR0. This is the bridge that we want to configure, the IP on this bridge. Double click that. And you see this is how we configured the IP that we use to communicate with Proxmox, to browse to the web interface of Proxmox. You'll see the gateway setting right here. This is what we're changing it to, .240. Okay, if we look at our Homelab diagram, .240 is the Ethernet interface of our Windows computer. So we're saying set your gateway to .240 and hit OK. And we got to do that on the other Proxmox server now that we have that. So cool. Now we've configured the gateway. Now it'll try to send packets to the gateway IP if it knows that it can't, the IP that it's looking for is not on its local subnet. There is another thing we got to do, because when I was testing this, I realized that the Windows host firewall was blocking packets. And that's normal because this is no longer an outbound, right? Well, typically, systems, their host-based firewalls allow outbound connection. But that's not what's happening here. Now that we set up that routing, right, that NAT, it is now receiving incoming packets. So the host-based firewall started blocking that. And just like anything else, we can literally pull up Windows Defender Firewall, go to inbound rules, go to new rule, and then start configuring everything. But we can do it with PowerShell because that's a lot faster. And with PowerShell, we can say, create a new firewall rule, name the firewall rule Homelab traffic, put it under the inbound section, right? This is inbound direction. Specify that this firewall rule only applies to packets coming from our isolated server, right? The isolated subnet that we've been working with this whole time, the 1.0/24, and allow it. We're just flat out saying allow those packets, right? We're going to allow those packets. Hit enter. Cool. You have now created your new rule. How do we confirm? It's here, right? It's in your inbound firewall rules now. I actually named it Proxmox Lab Access when I did this. So this is the rule that I created. This is that Windows firewall step. The action says, hey, if packets meet these conditions, allow the connection. What were the conditions? As long as the packets are coming from this subnet and it's coming inbound to your interface. We could have specified which interface to apply this firewall rule to, but right now it's just on all of our interfaces. Hey, if you find packets coming from that subnet and it's hitting one of your interfaces, apply this rule. So now we are allowing those packets. All right, this is a crucial step because you can do all this, but your host-based firewall would be blocking those packets, so nothing would work anyways. So cool, we have completed that step. All right, we're not out of the woods yet, because then we realized that the WinNat service, the Windows Network Address Translation service in Windows, for me, it didn't like the fact that, hey, I'm trying to forward and NAT packets coming from one physical adapter and going out another physical adapter. It didn't like that for some reason. Turns out that we needed to now leverage the awesome power of Hyper-V. If you don't know what Hyper-V is, it is Windows, it's Microsoft's built-in native virtualization capabilities. So how do we do that? You got to enable Hyper-V first. All right. You can do that by going to optional features. Go to optional features, and you can go to more Windows features. And you see here that Hyper-V is turned on. So we had to turn on the Hyper-V functionality. By clicking this top level folder, it'll do all these subcomponents as well. You got to enable that, and then you got to reboot your system. So cool. We completed that step. Now Hyper-V is turned on. But why are we turning on Hyper-V? Because we need to create a virtual switch and bind that virtual switch to our Ethernet adapter. So how do we do that? You can pop open Hyper-V, the Hyper-V management console, and start creating switches like that. But we're not going to do that. We're going to do our trusty old PowerShell, right? Because PowerShell is the easiest way to do this stuff. We create our switch by running this command, new VM switch, name it Homelab, and this is the beauty of it. Tie it to our Ethernet adapter. Net adapter name Ethernet. Allow management OS. Hit enter. And what does that do? That creates our virtual switch. But how do we know that, hey, it's using our Ethernet adapter, the physical network interface card? How do we know that the virtual Ethernet switch that we just created, how do we know it's using that? Well, if we look here at our Ethernet adapter, we can see that it's an Intel Ethernet connection 7. I don't know if it's a L219V, whatever. That's the manufacturer. That's the model, right? This is an Intel network interface card. Well, hey, if we pull up our PowerShell and we do a get VM switch, I had to switch to administrator PowerShell. Do a get VM switch. Well, hey, look. We have our Homelab switch that we created, and look what it's telling us for the adapter interface description. It's the same network interface card. So we know that this interface card is being managed by our virtual switch now. You want to see something else that's cool? Before, if we went to Ethernet, and we went to properties, and we went to Internet Protocol version 4 to look at its IP, notice that this is unchecked now. If we go to our virtual switch, we go to properties, and we go to IPv4, look, it automatically took the IP from our physical NIC. This is the 240 now. So now, if a packet comes and hits 240, it's hitting this virtual switch. So we did all that, right? We enabled routing globally. We enabled the functionality. We created the NAT. We specified the source IP. We opened it up on the firewall. We changed the gateway IP on the Proxmox nodes to say, hey, hit your gateway IP. We had to create a virtual switch to now manage that IP, right? We're still using WinNat. And now, theoretically, if an IP hits that gateway, our virtual switch will take it and route it to the Wi-Fi adapter out that NIC, and it gets natted. It turns into this IP, and that's as the packets are traversing the network, it looks like it's coming from this packet, and everything's stateful. So return traffic gets back to the Proxmox nodes. If we run PowerShell again, and we do a get netnat session, now this is telling us, hey, the Proxmox lab NAT that we created is working. This is a session. There are actual packets now being seen. Internal source Right now, it's getting packets from our 191 hypervisor, and it's sending it out my Windows computer's Wi-Fi adapter IP. That's how you know it's working. But there was another thing we had to do. Let's pop open a shell on our Proxmox, on our actual Proxmox hypervisor. We never configured DNS. Our Proxmox server didn't know where to send DNS requests to. It is not a DNS server. It's not connecting to a DNS. So if we do a cat etc resolve conf, I added a name server 1.1.1.1. So now if it goes out and those packets get all the way out, it knows how to resolve DNS names, right? And that's really important because we needed to run our apt update because it would start hitting endpoints, websites based on DNS name, not IP. And you see, it went out. Our NAT is working. So you might say, Cyberdarsh, why'd you do all this? Well, because the moment I put these hypervisors, these Proxmox nodes, the moment I put them on a switch and disconnected them from the home router and put them directly connected them to this Windows computer, they became isolated. They could not get out. The packets would stop at the Windows computer, and Windows, you can communicate with the Windows computer, but that was it. And actually, you couldn't even do that until we made changes on the host-based firewall. So now the beauty of what is happening after all those configurations is, again, there are two network interface cards on this Windows computer. Okay, there's two IPs. This one is now being managed by a virtual switch. This physical interface is connected to this switch in my home lab. Both of my physical Proxmox servers are connected to that same switch. They're on the same layer 2. But now when these IPs, when packets coming from these servers are hitting their gateway IP, which is the 192.168.1.240, it's being picked up by the virtual switch, right? The V switch. And it's saying, oh, there's a NAT configured. Oh, routing is configured. It wants me to send it. I've been instructed to send it to this IP out that interface. Now those packets change. Now it looks like all the traffic is coming from .25, which is now able to route on the home network. And now it goes out, hits its destination. It's stateful. It comes back and we're good. Now my Proxmox servers have access to the internet, but it's my Windows computer acting as that router, not my home router. It's the Windows computer acting as the router. The Windows computer is taking those packets and sending it to the home router. So there's double NAT actually. And actually in this case, there's triple NAT happening at this point. Proxmox to the Windows computer to my mesh node to the home router, and then it goes out. So there's 3 NATs happening. Is that ideal? No. Do you have to do this? No, right? There are many ways to achieve the outcome, right? So this was really cool. I did all that. I realized I couldn't update my Proxmox servers, messed around, did some testing. It wasn't easy, but now my Proxmox servers can update, and likely with some initial, more configurations, my VMs could also get out. With that though, we're going to see other networking hurdles because there's an OpenSense firewall there. So guys, hopefully you learned something. I know that was a lot. It's probably not the most straightforward thing. There's a lot of networking happening. Hopefully I didn't miss any steps. You know, I did my best to trace back on what I did when I was doing it. Obviously I was just in the heat of it. Hopefully you learned a lot, but the main takeaway is network address translation, layer 2 switches, why we had to change IPs in the first place, what the routing is enabling us to do, the added security benefits also, because again, any of these systems on my home network have no knowledge of these Proxmox servers. They are on different subnets. They cannot get to these servers. So there is security there, right? Yes, we did poke a hole technically so the Proxmox servers can get out, but we will follow security. We'll have defense in depth within the home lab. I appreciate it. Thanks for watching. If you have any questions, definitely just DM me, leave comments on the videos, and also just throwing it out there again. I do have my cybersecurity fundamentals course where I go through, I essentially took all my fundamental knowledge and thought about it from the perspective of a new learner and really condensed it as much as possible, as realistically as possible. And I put that in a course. So check out the link in my bio. It's 19 hours of course content. So yeah, appreciate it, guys. If you stuck with me, thank you. I appreciate it. See you in the next video.